Hello, good morning, good afternoon, good evening to all connecting from various countries in the world. Um, it's really exciting experience to be part of virtual AU this time. I am Varun Bhartiya, CEO and co-founder of Encircle Tech, and I welcome you all to this webcast on how machine learning can help you scale construction 2x. Very briefly, Encircle Tech is a CAD and BIM software development company that takes pride in solving challenging industry problems in AEC and manufacturing and makes time for people. We provide software development services to passionate innovators in industry so that they can focus on their core business. Now let's jump straight into the topic of the session. We are all familiar with the notion of machine learning for almost a decade now in domains of manufacturing and automotive industry. But when it comes to construction industry, the adoption of ML is quite low. The main reason we feel behind this is people are not able to get hold on how they can apply machine learning to their problems in the construction domain. There is also a myth around machine learning being only for the construction giants. However, that is not the case at all. ML as a solution for construction giants does more complex and robust tasks, while for the relatively smaller companies saves cost of manual labor. We need to understand that there is only one most important element that we need to apply machine learning in our workflows. That is data, lots and lots of data. Due to the nature of construction industry, I am 100% sure that most of the companies in the construction domain sits on a gold mine of data. There's an old saying that keeping your money idle is as good as losing it. And if I apply the same thing in the construction domain and also in the machine learning context, keeping your data idle is as good as losing productivity. So today I'm going to demonstrate and show you 5 examples of how machine learning can be really applied in the construction industry and how it can help you scale construction 2x. So the 5 tools or 5 applications are ML based OCR, ML based quantity takeoff, ML based scan to BIM, ML based mask detection solution, and ML based CAD voice assistance. Let's start with OCR. Now, field engineers and contractors of KTRAC have to manually verify and copy text data available from asset nameplates and labels as a part of handover data management. This activity is done manually and is less than optimal condition, uh, leading to human errors and wasted time. Overall, the process includes someone has to physically visit the location of the equipment, read the asset nameplates, and really type in those complex model number and serial numbers into the mobile app. And then later on, someone else has to verify the same. This whole process, when done manually, used to take 2 minutes on an average per asset nameplate. That's really huge. Now let's jump into a demo of what we have done using machine learning before I elaborate on the solution. So here I'm showing you KTrack mobile application. Of course, we pick up specific client, specific project, and we get into asset verification. Now we capture a specific photograph in this step so that we can apply OCR on this. This is a regular equipment from manufacturer Titus. We can also do a lot of editing or cropping on the image before it is done, and it can also be done automatically. But just look at the factory number. It's a complex, set of digits, model number, and so on. And when this is processed automatically using machine learning, you will realize that it has not just extracted the relevant text from the entire image, it has also mapped the text to specific category, like Titus is the manufacturer, Desvi is the model number, and then 624785 is a serial number. Although in the image it is categorized as factory number, but the intelligence has been built in so that it can categorize specific data to specific fields in KTrack mobile app. Let's look at some more examples here. Um, Here, an interesting use case is that this particular image has two manufacturers, Intertech and Daikin Industries. And it was able to nicely add both of these manufacturers together in the manufacturer field, and at the same time capture this complex model number and serial numbers, which are generally very difficult to type and error prone, uh, to capture accurately in the right categories. Let's look at some more examples. And I would also urge you to look at the complexity and the variations of the nameplates and asset plates. In this particular example, there are two different model numbers, some generic model number and the specific model number. So the system was intelligent enough to combine both of these model number in the model number category of the mobile app, along with capturing serial number and the manufacturer appropriately. If I take this forward, again, it is trying to capture complex model number and serial numbers as accurately as required, and then does support different use cases. Now, if I go back a bit and still talk about why to really apply a custom machine learning based OCR solution when there are so many available from the big giants, uh, Tesseract or anything like that. The interesting point here is some of these standard OCR solutions which are available in the industry are not very specialized for the construction domain. They tend to provide a good set of text, but they don't have intelligence on which text is relevant for a specific category. With custom OCR based on the machine learning, we can bring in all that intelligence, thus making OCR much more useful and applicable for the industry. Beyond this, we can also apply, and we have implemented a lot of pre-processing before the image can be provided to machine learning and OCR. For example, orientation of the image, then removing glare from the image, a whole bunch of pre-processing steps that just adds and improves the accuracy of the OCR. Now, let's look at how much of this solution actually helped KTrack and its users. So remember I mentioned that this entire process of capturing the data from machine learning from asset nameplates take almost 2 minutes for a user. Now this entire process was reduced using machine learning to just 4 seconds and also improve on the accuracy. KTrack on an average handles 50,000 assets in a year. So if I translate that into time saving, that's about 1611 hours or about 145 days of field engineers work. That's tremendous saving. So to sum it up, OCR improves internal and external operations by improving speed, improving accuracy, and decreasing the cost. Please, I would at this point I would like to remind our audience as well that you can add your questions in the chat window, and we will be happy to answer them one by one. Now let's move on to our next solution, ML powered quantity takeoff. As we are talking about BIM, everyone is accelerating towards adoption of BIM, but it is really sad that 80% of data exchange, or perhaps even more than that, still happens in PDF files. How many hours does it take for your engineers to sit with the construction drawings and perform quantity takeoffs or recreate the BIM model? My guess is that for some, this is job for the entire year long. Now imagine this being available to you in seconds, just few clicks. Our machine learning powered floor detection and quantity takeoff solution detects the floor plan in simple and complex designs. This could be spanning across multiple stories and wide spaces to give you solutions within seconds. It not only detects but also color codes the floor plan for ease of understanding and further operations. Once this is ready, you can directly jump to quantity takeoff, cost estimation, conversion of the 2D drawings to 3D, and so much more. Let's look at the demo, and you will realize how interesting the solution is. So what I show here is a set of floor plans. As you can notice, there is a whole bunch of complexities and the dimensions. And as you look at the legend, it is able to identify and categorize different rooms with different categories based on the entities available. So it is able to identify certain rooms as bedrooms, certain rooms as living rooms, and then undefined because it could not identify some spaces, and also kitchen and pantry. We also take this forward to identify specific entities in the drawing. Here we are identifying cabinets, windows, doors, even sink, so that you can do automatic quantity takeoff on all such elements. The output of such quantity takeoff is generated in a good Excel format, which you can easily use to process the next steps as we described earlier. Let's take a look at few more examples here. Another example of quantity takeoff, a floor plan, simple floor plan, 3 rooms, some cabinets and stuff like that. So it is categorizing bedrooms. It is also identifying the entities available there, and generating similar quantity takeoff Excel output. Let's look at that once again. I'm going to pause here for a second. So as you can see, it is able to identify sink, it is able to identify closet, electrical appliances, if any, and so on. So with that, I think it is clear that lot of these steps which are performed by your engineers manually with good amount of training can be automated entirely so that the process becomes simple and smooth. Again, feel free to share your questions via chat, and we'll be happy to take on and answer each of those questions towards the end of the session. Moving on to our third solution, ML powered scan to BIM. In last few years, 3D scanning has gained a lot of popularity. Scan to BIM can help in planning, coordination, inspection, and renovation. How much time does it take for an engineer to convert a point cloud data for 10,000 square feet space to a LOD 300 model? It's about 10 to 15 days. Size of the point cloud data is 10 times larger than the size of BIM model. While point cloud scanning is increasing, there are some limitations still seen in the industry. We have developed a machine learning powered scan to beam framework which automatically identifies and locates objects like a human and then color code them. Machine learning perhaps helps classification and segmentation. Goal of classification and segmentation is to classify input point cloud with one or more labels such as pipes, doors, windows, ceiling, floor plan, and so much more. With this process, we hope to simplify the process of BIMification and thus enable engineers to design better and optimize existing buildings. Again, without further ado, let me show you the demo. So what you see here in the video is a scan of a ceiling. You can see ducts, you can see pipes, columns, and so much more. Now, with the help of machine learning, we automatically identify such set of points and color code them. So it knows that these set of points are actually duct. It is actually categorizing them in specific category. It is not like duct pipe. So when we process this set of points, we already know that this set of points are pipes, and hence when we create a BIM model, this is to be translated into a pipe entity in Revit rather than a very generic element. So again, looking at this is the good Revit model created out of this point cloud data. Mechanical entities are created with respective parameters. So let's select some entities. If I select this pipe, it is, as you can see, it is created as a pipe element in Revit, not a generic model or just as a mesh entity. When I select a duct, it is a duct element that is created in Revit, and so on. We also looked at the accuracy levels. So as you can see here, all the point cloud that was captured, loaded in Revit, we created pipes from this point cloud data, and we compared the radius that our system could create with the radius that a human would create. So we modeled this pipe at 90.6 mm, while a human could model this as a standard size of 90 mm pipe. I think all of that leads us to a solution that can really transform the industry by converting such large amounts of point cloud into BIM models, which are much more usable and much more meaningful for the industry to utilize. So let's move on to our next solution, which is ML powered mask and no mask solution. This next solution is based on on-site safety during and post-COVID. We cannot rule out human presence on site from our industry. However, their safety is now an integral element of your planning. This solution allows you to detect the compliance and non-compliance of safety guidelines. In case any non-compliance is detected, concerned supervisors are alerted along with the screen capture of the worker. We are going to demonstrate this solution with the help of detection of mask. This solution allows you to identify people wearing masks and those who are unmasked. The same concept can be applied for other safety equipment as well. The solution can alarm operator if someone is found without a mask or essential safety equipment. Let me show you a demo of the same. So we want to protect our engineers, on-site employees, and it is very, very important. So we take in live camera feed, which could be installed at any location in your entire job site, and then automatically capture the any mask no mask violations. So as you can see, it's a simple camera feed. As soon as the mask is put on, it is detecting it with good 99% confidence level that the person is wearing a mask. You can see at different angles it can still detect that the person is wearing mask. Of course, the confidence level varies as it changes angle, and as soon as you remove the mask, it will capture and say with 99% confidence that person is not wearing a mask. Both of these are then like images, the frames are captured and sent over to concerned supervisor. This specifically transforms CCTV footage from being a very root cause analysis tool, which almost like happens after some incidents has happened and created a big chaos at the job site, to a tool which can become a preventive tool. So as soon as one small violation happens, if the entire system is alerted, and along with the data that is getting captured on regular basis, that XYZ person is found to be violating such norms more frequently, you can take appropriate actions based on all that data, thus making the entire system very, very preventive rather than prescriptive. With that, let's move on to our last solution. Uh, it's voice-based BIM assistant for BIM managers. This solution is designed by my team to demonstrate how BIM manager can quickly do review of models using voice commands. There are some commands that BIM managers and designers use very frequently. Our NLP engine learns these commands that are frequently used and executes them for you through the help of voice commands. A lot of progress has been made in voice-based assistance in the field of AI and with respect to multiple industries. But it is not so much applied and not very common still in the construction industry. Out of the box, voice assistants, libraries and tools do not work with construction industry. When you have a model open and you have specific names for entities in the model, you need a machine learning system that can really understand the context, so that when you call out a name, it can understand you're actually referring to a specific entity in the model rather than interpreting it as a generic voice command. The same concept that in machine learning, everything needs to be very contextual specific to attain higher accuracy levels. We did this in OCR, we did this in voice assistant just to improve on the accuracy of the voice assistants. Now let's look at the demo again for the voice assistants. This time I'm going to turn on the audio of the recording.
Okay, Revit. Select all type of windows.
All type of windows are selected.
What is total count of selected windows?
Total count of selected windows is 19.
What is the elevation of second story?
Elevation of second story is 9.84 feet.
Add a note. Increase the elevation of second story by 2 feet.
Note added.
Zoom in on second story. Replace walls from second story to timber clad.
All walls from second story are replaced with type timber clad.
So as you saw, this makes life of reviewer very easy, and thus makes it a very smooth process. It's almost like having a conversation with your colleague, and the system can take as many actions as you can throw at it and do that much more faster. So with this, we demonstrated a set of tools that you can really apply in the construction domain and solve these problems, in interesting industry problems, and make the most of it. Uh, so the next question really is when to apply machine learning. So you can apply machine learning when it is not possible to code the rules due to large number of factors affecting final output you're looking for. When there are large amounts of variations which you cannot really easily estimate and draw patterns from, then machine learning tools can help create such patterns and support all kinds of use cases. It should be applied when it is not possible to scale using traditional methods. So machine learning solutions are really good at solving complex large scale problems. To further drill it down, start by distinguishing between automation problems and problems that need automation with learning. The later is perfect scenario to use ML. Last but most important point to consider is that you have high amounts and large amounts of good quality data related to problem that you are trying to solve. The data will be used to train machine learning engine for the desired output. So I hope you could gather a takeaway or two from this session. And before we end this session, I would like to um, uh, suggest that if you want to try out any of these solutions, please visit on this link, also available in the description, and upload your data. We are happy to process some of these and generate the results for your own set of inputs, your own set of data. Needless to say, we will keep all your data very confidential. If you want us to execute any kind of contractual formalities before you share that data, we are happy to comply. Thank you everyone. Thank you audience for joining us today. I now look at any kind of questions we may have. Thank you.